Hello everyone, I am here with lesson 1.3, solving equations with variables on both sides of the equation. So the steps to solving an equation with a variable on both sides are listed out, and again, I give you the order, but not every single problem will have parentheses, not every single one will have like terms. This just gives you kind of a step-by-step on what you should do. So yeah, step 1, you should always remove parentheses on either side of the equal sign separately first if you see them. After they're gone, then combine the like terms on either side of the equal sign. Step 3, and this is where it's a little different than what you're used to. Because you're going to have a variable term or a variable on both sides of the equation, you're going to want to eliminate one of them from one of the sides. So basically, to eliminate something, you add the opposite of it. That creates a zero pair. So you'll end up adding the opposite of one of the variable terms to both sides of the equation, and you'll see after that step that you're going to be left with either a 1 or a 2 step that you can solve as usual. So let's try a few. These ones I actually think you have not seen before. So here is what it looks like in the basic form. So we're still going to draw our line down from the equal sign. And step 1 says to get rid of parentheses. Well, there aren't any. Step 2 says to combine like terms on either side. Now, I know that there's a 4y here and a 3y there, but you can't just combine them into 7y because they are on separate sides of the equal sign. So when I say to combine on one side versus the other, that's what I'm talking about. So there aren't any like terms here, and there are not any like terms over there. Step 3, add the opposite of one of the variable terms to both sides. It doesn't matter which one you pick. I usually just think about the math problem I'd have to solve to make it easier. So we would either have to add a negative 4y to get it to cancel out here, or a negative 3y to get it to cancel out here. I'm going to go with adding the negative 3y, so I would end up with a positive coefficient, just because people are less likely to make mistakes when it's positive. So I want this 3y to go away so that I have variable term only on one side. I'm going to add the opposite of that 3y. So 3y plus negative 3y over here, those are like terms. The 17's not a like term, so 17's still there. 4y and negative 3y are like terms, and 4 plus negative 3 is 1. 1y is y. And I still have that plus 6 because 6 doesn't have a y after it. And now this is what I'm talking about for step 4. You're left with, this is just a 1 step. I want y by itself, so I would add a negative 6 to each side, and I can see that y equals 11. Now when you're trying to check these, when you plug 11 in, you need to make sure that one side does equal the other. So you would take 4 times 11 plus 6 and see if that equals 17 plus 3 times 11. You can use a calculator if you want, but 4 times 11 is 44. 44 plus 6 is 50. I have to multiply first, so 3 times 11 is 33. 33 plus 17 is 50. One side equals the other, so I know that I'm right. And again, I'm not going to check every single one. I just want to make sure you know how to check it. Because when you take a test, every single one of you should be able to get 100% on a solving equations test because you can check every single answer. So please, again, get in the habit of it. All right, next one, draw our line down. Again, there are no parentheses. There aren't any like terms on this side, and there aren't any like terms on this side. So step number 3, I have to pick one of those variable terms to get rid of. I'm going to change my signs here so I know what I'm dealing with. And again, your options are, you can add 2x to each side, which would bring all the letters to this side, or you could add 7x to each side. I'm going to choose to add 7x because that will give me a positive coefficient. So to cancel out this negative 7x, because I don't want variables on both sides of the equal sign, I'm going to add a positive 7x. Oops, I'm going to do this to both sides. So negative 7x plus positive 7x, those are like terms, they're opposites, they're gone. Negative 5 is left over here. And over here, I still have this 15, it doesn't go with anything. But I have a negative 2x and a 7x. Those are like terms. And when you take negative 2 plus 7, you get 5. So this is my 2-step equation that I'm left with. Again, we're trying to solve for x, so let's get the 5x by itself first. We'll add a negative 15 to each side. So those are gone. 5x would equal a negative 20. Then to undo multiplying by 5, I will divide by 5. 5 divided by 5 is 1. X is equal to negative 20 divided by 5, which is negative 4. And again, to check it, plug a 4 into this side, plug a 4 into that side. Or sorry, negative 4 into this side and into that side, and make sure that they equal one another. Okay, this one here is usually a hot button. It causes trouble. But if you go ahead and add the opposite here, we see that they're not the same values here. So I have a negative n, I have a positive n. You want to get all the n's on one side together. That means I can either eliminate this one by adding n, or I can eliminate this one by adding a negative n. I like positive coefficients, so I'm going to choose to add n to each side. When I combine like terms over here, a negative n plus a positive n are opposites. They're gone. 9 equals. Remember that n plus n is not n squared. N times n is n squared. N plus n just means we have 2n. And think about it. You have 1n plus another 1n. That means 2. So 2n. And I still have my 5. I don't have 7 n's. I only have 2 n's and then 5 additionals. So now we're at a two-step. I'm going to add a negative 5 so that I can get the variable term by itself. 9 plus negative 5 is 4. And then in order to get n alone, I'm going to divide by 2. 2 divided by 2 is 1. 1n is n. And 4 divided by 2 is 2. All right. Oops. Let me scooch it up a little bit. There we go. Voila. Okay. Here we go. Draw the line. So when you look at this one, yes, it looks a little different because I don't have an extra number on this side. And I know that I'm usually gung-ho on having positive coefficients, but I wouldn't move this over here because then I'd have to move the 20 over there and it just creates an additional step. You could, if you absolutely had your heart set on it, you'll get the same exact answer. But for this one, I'm going to add a negative 2x. That allows me to have all the letters on one side and the numbers on the other. Or, sorry, all the variable terms on one side. So when you take a negative 3x plus another negative 2x, that means you have negative 5x. The negative 2x and the positive 2x are gone. I'm left with plus 20, which means positive 20. Now I have a one-step. Divide by negative 5, and x equals negative 4. All right. So those are the basic ones. We're going to do a few more that have some parentheses and have some like terms in that before you solve them. I've given you some more space, as you can see. So draw your line. And the step 1 that we haven't had to do just yet is remove parentheses. And the step 2 that we the step 2 that we have not had to do yet was combining like terms. So I'm going to change all my subtraction to addition. And let's get rid of these parentheses over here. Remember, take the number next to the parentheses and multiply it by each one. I like to think of this as 5 cookies, and that's Ellie, and that's Ethan, my kids. And if I give Ellie 5 cookies, I have to give Ethan 5 cookies too. Otherwise, whoo, trouble. So negative 5 times n, that's negative 5n, plus negative 5 times negative 9 is 45. If you didn't change your signs, you may have written minus 45 instead of plus 45. Please be careful. Now on this side, I don't have parentheses, but I do have some like terms. So let's combine those. They're on the same side, so I'm allowed. 12n plus negative 2n, well 12 plus negative 2 is 10, so I have 10 n's plus this 15. Now this looks like the ones we just did. So I have variables on both sides. I'm going to pick one of the variable terms to get rid of. I choose this one so that I can have a nice positive coefficient. So 10n plus 5n is 15n, plus we still have our 15. Negative 5n plus positive 5n, 0, gone. Don't ever write 0n, because if you have 0n, 0 times n is 0. So you have nothing. You're good. They're gone. And that equals 45. Now we're just in a regular two-step. I want this 15n to be all by itself. So I will add a negative 15. So 15 plus negative 15 are gone. I'm left with 15n, and 45 plus negative 15 is 30. Don't you like it when I make them come out to nice purty numbers for you? Alright, so I want 15 to go away. It's being multiplied by n, so I'm going to divide by it. 15 divided by 15 is 1. 1n is n. And 30 divided by 15 is 2. Again, if you want to check this, you're going to plug 2 in here. So you take 12 times 2 plus 15 minus 2 times 2, hit enter, see what you get, and then do negative 5 times the quantity of 2 minus 9, close those parentheses, hit enter, and you will get the same amount, I promise. But that is how you check it. Okay, math wouldn't be math without fractions. At least I made it nice. It's just 1/2 in there. Those aren't bad. So step 1 says we should get rid of parentheses first, so let's do that. 6 times 1 is 6. 6 times 1/2, that means this, which means this, which means this. Right? 6 times 1/2, or half of 6, it's 3. And don't forget about the x there. And over here, 2 times x is 2x. 2 times 1 is 2. And again, we have one that looks just like the others on the opposite side of the page. We have a variable on both sides. Choose one to get rid of. I would rather do 3 minus 2 than 2 minus 3. So I'm going to add a negative 2x first. So now I'm left with 6 plus, when you take 3 plus negative 2, you get 1. And 1x is the same as x. Negative 2x, positive 2x, gone. You're left with plus 2 or just positive 2. One stop. Isn't it nice? Let's get rid of this 6. We'll add a negative 6 to each side. X is all alone, and 2 plus negative 6 is negative 4. Okay, now here is the next set, your first introduction to special cases. You're going to find in algebra that everything has some sort of special case to it. So first exposure, not your last exposure to special cases. When we solve it and get through the end, you'll see why it's a special case. So let's go about solving this like we normally would, because usually you can't recognize special cases right off the bat. And step 1 is, let's get rid of parentheses. Well, 3 times 2 is 6, and 3 times 5x is 15x, and I have 15x on this side. Okay, so now I have variable on both sides. Remember, if I have a constant and a variable term over here, but I don't have a constant over here, let's move all the variable terms to one side. So I'm going to add a negative 15x, and maybe now you're seeing why this one's special. Those are gone, and 6 equals, well, when you add 15x plus negative 15x, isn't it 0? And my question to you is, does 6 equal 0? The answer, of course, is no. So when you end up having variable term that cancels out, and you get 2 different values, no variable, just 2 different values on either side, that means that there is no solution. Because 6 does not equal 0, this equation has no solution. You cannot solve it. Crazy. Now the next one here. This is a special case, but for a different reason. Do what you normally do. I'm going to change my signs because that's what I normally do. And I'm going to get rid of the parentheses. Negative 2 times 4y is negative 8y. Negative 2 times 1 is negative 2. And I have a negative 8y plus a negative 2 over here. Whoa. I have the same equation on either side. If you notice that, right off the bat when you're doing your homework assignments, you can just stop there and say, hey, this equation equals that equation. I know it's infinitely many. For this point, I'm just going to continue solving through it so you can see why it's infinitely many, and we'll talk about that term in just a minute. So I would want both the variable terms to be on one side, and I'd want all the numbers, the constants, to be on the other. So I'm going to add an 8y, add an 8y. And negative 8y plus 8y is 0, and 0 plus negative 2 is negative 2. And negative 8y plus 8y is 0, and negative 2 equals negative 2. Now, in the previous example, 6 did not equal 0. But in this example, negative 2 does equal negative 2. That means that there are infinitely many solutions. And what infinitely many means, it means that any number that you plug in for y works. There is not just one answer. The answer is every number. So we call that infinitely many instead of every number because it sounds really fancy. So no solution happens when the variable terms cancel out and you're left with one side not equaling the other. Infinitely many happens when the variable terms cancel each other out and one side does equal the other. So again, This one, no matter what value I plug in for x, I cannot make that equation true. I can't make one side equal the other. With this one, no matter what value I plug in for y, every single value will be true. All right, we're almost done, but again, it is story time. Your favorite time of the day, math story time. Okay, so basically what I want you to be able to do with this is apply it to a real life scenario. And someday you might want to join a health club and you'll be comparing rates and you'll actually use this stuff. I have used it. So Health Club A, they charge a one-time fee of $44 to sign up for their club. Then, in addition to that $44 one-time fee, you have to pay $30 a month. Health Club B charges $99 one-time fee, and they charge $25 every month. My question to you is, after how many months will the total cost be the same? So I'm basically asking you, when will the Health Club A cost be the same as Health Club B cost? After how many months? What you need to do is, you need to set up these equations equal to one another. So we have to write an equation for Health Club A, and we have to write an equation for Health Club B. So Health Club A charges $44 one time plus $30 per month. So this 44 happens once. I'm not going to put a letter after it. It's a constant. It happens one time. In addition to that $44, I pay $30 a month. Now, I didn't tell you how many months, but if I went for 1 month, I'd pay 30 times 1. And if I went for 2 months, I would pay 30 times 2. And 3 months would be 30 times 3. So we're just going to say we went for M months because we are trying to figure out what M is. We're trying to figure out how many months will it take for them to be the same. So this is Health Club A. I want to know when it's equal to Health Club B. So the equation for Health Club B, it says that they charge a $99 one time, not per month, so I'm not going to put an M next to it, plus $25 per month. So basically with these, whatever happens one time is a constant. Whatever happens over and over again gets to be your variable term. So this equation should look just like the ones on the front. There aren't any parentheses, there aren't any like terms, so I'm going to start off by getting all of the variable terms on one side, and I'm going to get rid of this 25m so that I can have a positive coefficient. So over here, I still have this 44. 30m plus negative 25m gives me 5m. Here, 25's cancel each other out, and I'm left with 99. Now it is a two-stepper. To get rid of this 44, I'll add a negative 44. I'm left with 5m equals, and 99 minus 44 is of course 55. To solve for m, I just need to divide by 5, and m equals 11, so this means after 11 months, both healthcare companies will cost the same amount. So if you were going to make a decision, you would want to figure out how long do you plan on having a membership for? Do you plan on having a membership for more than 11 months? Because if you do, you'd want to go to the one where you only pay $25 a month instead of the 30. If you plan on going to this workout health club for less than 11 months, you might just want to go with this because there's a lower one-time fee. Math, real life, it's crazy. It's everywhere. Okay, so a little geometry connection because it's super duper important, especially for you all who are going to take geometry next year. Perimeter. The perimeter of the rectangle is equal to the perimeter of the square. What are the side lengths of each figure? This is going to be a doozy, but it's a fun doozy. So first off, remember that perimeter is the distance around an object, right? And I've given you two sides, but I've given you a square here, and I've given you a rectangle there. So we know that this side and this side are the same, and this side and this side are the same. I know it's silly to have two different expressions here, but this one, they're going to represent the same thing, I promise. Okay, so when you see this, basically we're saying that the perimeter of this equals the perimeter of that. So I'm going to write an expression for the perimeter of this and set it equal to the perimeter of that. So 5x minus 3, that means this is also 5x minus 3, and this is also 3x plus 1. This is 2x, and this is 4x plus 2. So basically, to find the perimeter, I want to put all of the x's together and all the constants together. So I have 5, 10, 11, 12, 13, 14, 15, 16 x's. As far as constants go, after I add the opposite here, I see I have 1 plus negative 3 plus 1 plus negative 3. So a negative 3 plus another negative 3, negative 6. Negative 6 plus 1 is negative 5, plus another 1 is negative 4. So the perimeter of this shape here is 16x plus negative 4. Now, the problem said that the perimeter of that is equal to the perimeter of this. So we're going to do the same thing with a rectangle now. Let's combine all of the x's together. So I have 4 and another 4, which are 8 x's. 2 more is 10, 2 more is 12. So 12x, and then I have 2 and 4 in the constants department. So 12x plus 4. Okay, now we just have to solve it. I am going to get rid of this because I'd rather do 16 minus 12 than 12 minus 16. So I will add a negative 12x to each side, or subtract 12, again, whatever floats your boat. I'm left with 4x plus negative 4 equals, those are gone, 4. Now I have a two-step. I will add 4 to each side. I never quite make those lines long enough. And 4x will equal 8. Divide by 4, and x equals 2. I love solving this kind of equation. They're so much fun. I hope you're enjoying yourself too. So we're not actually done, because the question was, what are the side lengths of each figure? So if x equals 2, now I have to figure out the side lengths and plug it in. So if x is 2, then that means this side length is 5 times 2 plus negative 3. And 5 times 2 plus negative 3, I'm going to zoom in a little bit here, means 10 plus negative 3, which gives me a 7 for that side. And here I have a 3x plus 1. Well, it's a square, right? So this better be 7. We'll test it just in case. 3 times 2 plus 1, whew, thank goodness, it's 7. So the perimeter of this would be 7, 14, 21, 28. I'm going to write that down. Make sure that one of the perimeters equals the other. And the side lengths of this figure here, so 2x would mean 2 times 2, so that side length is 4. And this side length would be 4 times 2 plus 2, and 4 times 2 is 8 plus 2 is 10. So that means I have 10, 20, 24, 28. Whew! Both perimeters are 28. I will see you tomorrow. You're done for tonight.